Okay, we're going to do a teardown of this black box. So it is an animatronic Halloween Boo in a box. And the eyes are from Adafruit. They had some old firmware in them that crashed and they stopped working, and I had to load some new firmware in there. I am gonna pull that cable out. So we can get a look at the rest of it. And just to keep them running in the background. Okay, so this mechanism, we've got 22 3D printed parts at least. There's the two big feet. They're big enough to have hockey pucks in them for stability. There are two arms on a servo in the front here. And we're going to have to be able to spin that around. So you can see the servo motor back here, and it rotates to make the arms extend through these slots. I could have made the motion a little bit more uniform, but I thought this motion would be fun to do. That's how it works. Normally the platform, which raises the head, is normally up when these arms are extended, so they don't run into these little struts. And it's another servo motor. A single servo motor raises the platform, and they are on this fancy, oh yeah, they're held by the power. I have to turn the power off in order to move this one. So we can see that there are 4 pairs of struts here. They're like a bit like scissor joints, but not quite. And the way they work is they have a hinge at the bottom, they have a hinge in the middle, and a hinge at the top. And when they're extending, they can only extend, they pivot only in one direction, so that the top, all these axles remain parallel to each other as they're extending, which means that this whole arm cannot tilt because it's rotating about an axis in this direction, so it can't tilt. The axle prevents it from tilting. Likewise, this guy here, which is at right angles to the other one, he's pivoting up as well, and he can't tilt. He can only go straight up. And what that does is it keeps the platform at the top here completely horizontal. So the head will always stay horizontal without tipping, because these 4 strut systems cannot tilt. They only allow it to go straight up. And there's a single servo motor that drives the whole thing through a crank shaft and a connecting rod. So it is the thing that provides all the lift force, but And you can see in here that it's got room for this arm to swing down through the chassis. So it's sort of fortunate that he's raised up on legs, because the servo arm crankshaft does come down below the chassis. So that was quite complicated to actually design and build, but it worked. This platform raising system, let me turn the power on, works very well. You can see the servo motor really does a good job of raising a long distance with a single motor, and it keeps the platform at the top horizontal. So that's a really nice mechanism, and it's just strong enough to lift this whole box up with the head on it, because when it's over here, there's an awful lot of torque needed at this point in the stroke. When it's near the top, it has no problem, because it's got good mechanical advantage. So that's the basic mechanism. Now, you know, this system can raise up off the feet, so it really just sits on top of the legs, and that's an explanation of how it works. So I'm really glad that this platform raising system worked with the single servo motor. I think I'm going to be able to use that kind of mechanism for future kinds of animatronics. And it took a little bit of doing. I kind of trying to visualize how all these things work. There's, you know, 20 moving parts, and they have a lot of potential for interference if you get it wrong, and I did get it wrong. The initial one, I had some interference with the joints at the top. I had to reprint the top so that I could separate these enough that they would work the way I wanted. But ultimately, it all came together and worked well. So I'm pretty pleased with this project, even though it's just kind of a little frivolous Halloween thing. I did learn a lot about this kind of mechanism. I didn't take a lot of time to make the arm mechanism really fancy. I could have put connecting rods and so on here to make it so that the arms would just move at some specific angle, but I kind of like them flopping around like they do. And let's just have a quick look at the circuitry over here. So we'll get that guy's hand out of the way. What we have is the servo controller, and I have another one that I could use for the other arm, and there's an extra power jack for it, and it works okay, except that this one doesn't have enough travel to get the arms fully extended, so I really needed to use the same controller twice, unfortunately. So there's power coming in, which is just 5 volts from one of the power supplies over there. There's a connector here for this little speaker, and here we have a little audio chip that can store files and play them back. I have 6 buttons here that can select a sound to play.
I can see! I have legs!
Sounds like Eddie Murphy. That's a very loud little speaker. This chip is kind of cute. You can transfer files to it, just MP3 files, and they play in response to each one of these buttons. There's, I think, theoretically you can get 21 different sounds that will play, and they can be long. This thing has a lot of memory, but I'm just using short sound clips. And you can also control it from a computer, so I put a connector on here that allows you to connect this up to a microcontroller or something to get even more capability out of the sound. Now, I really like these little strip boards. Let me disconnect that so we can have a look at it. These little strip boards, you can see how neat it is. All the wiring is just done with some vertical jumpers, very neatly. And on the back, all the horizontal connections are already made for us. We just have to disconnect the ones that we don't want. And I have a spot face cutter tool that makes that very simple. But having these printed tracks already on the card really makes many of the connections for you, and so you can do all the horizontal connections on like a double-sided printed circuit board with just jumpers going in the vertical direction on the top. So normally you could make a card which was a double-sided card and just had the two traces going this way on the top and this way on the bottom. But it allows you to really wire them up in a neat form. There's no wires crossing each other. I didn't have to use insulated wires because they're not crossing each other.
All systems normal and functioning.
I just grabbed a bunch of files off the internet and
I'll be back.
Guess who said that? All right, so that's the project in a nutshell.